Okay, great. So I start. Hi everyone. So I'm Barbara, the founder and CEO at Interstellar Lab. So at Interstellar Lab, our mission is to help humans live in a sustainable way on Earth first, and then in the future in space. So what do? We developed environmentally controlled module where you can grow food while recycling air, water, and waste. Our first product that we started selling on Earth is called the Biopod. It's a next generation greenhouse, which is a ground base of 55 square meter, 10 meter long, 6 meter wide, 4.5 meter high, and it's allowing to get a growing area of 290 square meter. It's a very advanced greenhouse where we develop several technology that we're patenting, and that is recreating a completely controlled environment where you can grow pretty much anything. So we've developed we developed a patented membrane that is combining several material, aerogel, ETFE, and PTFE. Aerogel being commonly used in aerospace to recreate a shell where we can protect what everything is inside the dome, but also we can get the light in, and so get also very good insulation property. Inside the dome, we create a sealed environment that is completely pathogen-free with an airlock, so we don't have any air going inside that is bringing pathogens. And we have a composite base that is foldable, so which makes our device very easy to carry and to deploy under any environment. Inside the dome, we have integrated several systems. We also have a patent pending in the integration of the several systems, from the water treatment system where you have a water tank. The water is being cleaned directly inside the dome. It's connected to a nutrient dosing solution, which is also connected to an advanced atmospheric system when we use CO2 scrubber, an O2 generator, and dehumidifier, which are technology that are commonly used in the aerospace industry, more specifically in the International Space Station. Last but not least, the third type of system that we've been developing ourselves is aeroponic systems, where you can grow different types of crops. So we have 4 different aeroponic systems that are under patent, and we are combining them with a substrate-based greenhouse. So pretty much we can offer to our customer any solution they need to grow any types of plants, from vegetables to flowers to bulbs, and I'll detail that a little bit more. Everything is completely autonomous. So what we've been doing is developing a software simulation tool where you tell us what you want to grow, and then we help predict the yield. So if you want to grow kiwis, we can tell you how much you're going to yield and how much you're going to grow over time. Everything is completely automated inside. So as soon as we know what we want to grow, we can predict the needs of water, of nutrient solution, what's going to happen with the CO2 and the CO2 need, and then we program our hardware to basically do everything automated and then activate it depending on the data that we're getting from the several sensors inside. What can you grow inside the Biopod? So pretty much everything. We've been testing a lot of plants. Right now we know that you can grow over 300 high-value plants. Our main customers right now, they're in the cosmetic and perfume industry, in the pharmaceutical industry, and also into food production. We also have several customers that are interested to taking our Biopod to recreate specific climatic condition, to grow endangered species, and to go towards biodiversity conservation. This is a flower, an iris flower, that we've been doing as a use case from one of our potential customer. Iris is a very commonly used in the perfume industry. This is vanilla that we've been growing in our demonstrator, in our prototype in Paris. We had very, very impressive yield rate. So it's growing 50 times faster than what is traditionally growing in the traditional agriculture. And this is another use case of dahlia flower that we've been growing in our prototype at the office, also for one of our customer. This one that is interested in getting dahlias because we're getting less and less producers actually in the world right now. So our product, compared to traditional agricultural system, it's reducing CO2 emission and the consumption of resources, land, water, and air. So we save water, we boost the yield, and we reduce the energy consumption because of the innovation we've been bringing both on the patent and all the systems that we have inside. The opportunity on Earth first, and then in future in space. So Earth is our market right now. This is where we are selling. We have over 70 pilot demands. So those are firm LOIs signed with very big brands like LVMH, like Chateau Farm, which is a hospitality brand. And then there is an opportunity in space, but which will come a little bit down further on, in our path. So Artemis plan is by 2023, 2024, they're going to start sending humans back to the moon. And we're planning on collaborating. We're actually already collaborating with NASA and ESA to develop an adaptation of our system for lunar application. But back to Earth, how we're making money here. So we're selling the hardware at 200K, and then our customers are paying a recurring fee, a monthly fee to access the data and the software and to access the resources. So we can give them fertilizers and new seeds to grow the plants. The pipeline, so right now we have over 70 demands. So demand means LOI. We haven't taken any money right now. We are waiting for the end of this year to take the money and the final deposit. We first wanted to secure our supply chain. Our customers are divided in 3 categories. For research, so space and science, where they're doing a lot of phenotyping and testing in control environment, how to grow specific plants. Our biggest market are corporates, so cosmetic, fragrance, agri-food, where they need our technology to grow in enclosed environment specific plants, and we're very competitive to solutions existing on the market. And last but not least, cities and resorts, where the preferable solution to containers, because we're more efficient, plus we're beautiful. So the sales cycle, I'm losing the time. The sales cycle right now, everything has been super organic. So they reach out to us during 3 to 5 months. We do testing in our lab when we test the different plants, and then we present it to them. The good thing is that as soon as we get them for 1 biopod, they're interested in buying 5 to 10 biopods because they want to replicate to be able to grow much more of the product that we're selling to them. The competitive landscape. So basically, if you need a growing area of 180 square meter, you need 3 units of biopods, and we take much more land space compared to container and other farms. We're also cheaper as a startup cost compared to them. We are very quick to deploy compared to existing greenhouses, and we consume. It's still a bit more than a bioclimatic greenhouse, but it's much less than a shipping container. Plus, we are regenerative. So how are we going to scale from 30 units to 1,000 units? As I said, as soon as they buy 1 biopod, they're interested in buying 5 to 10 biopods, which is a very good market as soon as we enter and we get customers. So this is our plan for growing 300 units, starting 300 units. This is when we will be able to accelerate the scaling and reduce the cost of manufacturing of our biopods. Manufacturing a biopod costs 120K right now. We can decrease to 60K, and we are selling it at 200K. So that's a pretty good margin, which is allowing us by 2024 to be EBITDA positive. This is our estimation when it comes for revenue, 6 million next year, 2023, 15. And then we can scale up by basically having the capabilities to give everything to our customer. This is the team. Okay, I've been too long. This is a very international experimented team. This is our manufacturers that we are working with, very, very good partners. We raised 1.2 so far, and right now we're raising a 3 million round. It's a safe note, 15 million caps, 20 million discount. Half of the round is committed, and we're raising it to finalize the construction of 3 demonstrators, turn the orders into revenues, and scale the manufacturing from 1 month to 1 week.